Exercise 711 is sums and differences of areas. The important things to keep in mind are that nothing beats a good sketch, and you will need to find where the curves intersect with each other. So example 1, we need to find the area enclosed between the curves y equals x squared, y equals 6 minus x, and the x-axis. So I've sketched that here, and the area that has those three boundaries is this area here under the curve. It's got the x-axis, it's got y equals x squared, and it's got y equals 6 minus x. One way we could do this is as a sum of areas. So we could divide it right down here, call this one area 1 and this one area 2. So our area is just area 1 plus area 2. So area 1, now in order to find that, we're going to need to know this point where the curves meet each other. So we need to know where does x squared equal 6 minus x. In other words, x squared plus x minus 6 equals 0, x plus 3x minus 2 equals 0. So x equals negative 3 or 2. So negative 3 is up here somewhere. This one is where x equals 2. You don't need to know the y coordinate there, just the x coordinate. So area 1 is the integral from 0 to 2 of x squared with respect to x. And area 2, we could do it as an integral from 2 to 6. We need to know this point 6 as well. That was a nice easy one to find in this case, but sometimes you will need to make y equals 0 to find the x-intercept. You can do it as the area of a triangle. If you find this height here, which is just the y coordinate when x equals 2, so when x equals 2, y equals 6 minus 2 equals 4, we can use that triangle, so half base times height. So let's do that. So x cubed on 3 from 0 to 2 plus half. So that was 2 there, so that distance is 4, and that distance is 4. Half times 4 times 4. Sub in the 2, so 2 cubed on 3 minus, sub in the 0. 0 cubed on 3 plus, that's 8. So 8 on 3 plus 8, that's 0 obviously. 8 on 3 is, what is it? So 8 on 3 plus 8, so 2 and 2/3, so 10 and 2/3 units squared. So that's an example of a sum of areas. Let's look at an example of a difference of areas. Find the area enclosed between the curves f of x equals sine x and g of x equals cos x on the domain pi on 4 to 5 pi on 4. Now I have sketched that for you. I have shown you that pi on 4 and 5 pi on 4 is where they meet, but if you didn't have that sketch, you would need to find where does sine x equal cos x. Pause and have a go if you like. The trick here is to divide by cos x. Now we know sine divided by cos is tan x. Cos divided by cos is 1, so we're saying where does tan x equal 1? So all stations to central. Tan is positive up here and down there. Just from our standard little triangle, 1, 1, root 2. That's pi on 4. So x equals pi on 4. And in this quadrant, it'd be pi plus pi on 4, which is our 5 pi on 4. So that shows those 2 points of intersection there. Now to find this area, what you do is you do the top curve minus the bottom curve. So the top curve is sine x, the bottom curve is cos x, so it's the integral from pi on 4 to 5 pi on 4 of the top curve minus the bottom curve. Now, one thing you can do is you can subtract either way if you put absolute values around the whole thing, but it's easier just to go the top curve minus the bottom. Top minus bottom. You can completely ignore the x-axis. That doesn't matter. You can pretend it's not even there. If you shifted the whole thing up, if you added 3 to each of those, you only need to add 1 to each of those, but anything more than 1 to each, it would shift it up. They'd all be above the x-axis, but the area would not be changed. So just ignore the x-axis, the top minus the bottom. So let's integrate that. So sine integrates to negative cos x, minus cos integrates to sine x, and that's from pi on 4 to 5 pi on 4. So let's substitute in. So negative cos of 5 pi on 4 minus sine of 5 pi on 4, so that's 5 pi on 4 substituted in, minus negative cos of pi on 4 minus sine of pi on 4. Now I'm going to do exact value. So cos of 5 pi on 4 is negative 1 on root 2, so it's the negative of negative 1 on root 2, so just 1 on root 2. Sine of 5 pi on 4 is also negative 1 on root 2, so the negative of that makes a positive, 1 on root 2, minus cos of pi on 4 is 1 on root 2, but that, actually look, these two negatives here, let's factor them out and make that a plus. So plus cos of pi on 4, which is also 1 on root 2, plus sine of pi on 4, which is also 1 on root 2. So we have 4 lots of 1 on root 2, which is 4 on root 2. It's always good to rationalise, so times root 2, root 2. So that equals 4 root 2 on 2. 4 on 2, of course, is 2, so 2 root 2 units squared is our area there. So that's a difference of areas.